Hi, welcome to my video on review 1 on circles. This is reviews on videos 1 to 13, and as in all reviews, it can be marked as a quiz, and this one is marked out of 34. So give your mark for each question, total up the pages, and when you get them all done, total up your score, put it over 34 and convert it to a percent. Here we go. And all the questions are in order of the videos. A chord that passes through the center of a circle is called the diameter. A chord goes from one point on the circumference to the another point on the circumference going through the middle. It's called the diameter. Give yourself a mark. If a function is linear, then the domain is the set of real numbers. The inverse of that is if the domain of a function is set of real numbers, then the function is linear. So notice we have a switch around. The if becomes the then, and then becomes the if. And so there's the inverse. And if the domain is real, then the function is linear. That's false. Because let's take the parabola, which is this one, y equals x squared. The parabola has a domain of reals, but it's not a linear. So there's one example, and we could have, there are many, many more, but I just picked the parabola as a function. Another one could be the cubic function is a function that has the domain of reals, but again, it's not a linear. So if you got the domain inverse right and you got the reason right, give yourself 2 marks. And again, you can pause your video for each question, work out your answers, and then press play to see if you're right. Number 3, can. If an inscribed angle of a circle intersects the diameter, then the inscribed angle is a right angle. Can the statement be written as an if and only if statement? Explain. And if you can, write it in the if IFF form. So the inverse. So if we can write, I'm going to write the inverse, or the converse, I should say, not the inverse. I'm going to write the converse, and the converse is if an inscribed angle of a circle is a right angle, then the inscribed angle intercepts the diameter. And that converse is true. So there's the statement, the conditional sentence at the beginning. This is its converse. And the converse is true because if you have a circle and you have a diameter going to the center O, and you draw an inscribed angle which has 2 chords with a common endpoint, and that inscribed angle intercepts the diameter, then this is a right angle. And that's true. Therefore, if we take this statement and put if, so we leave off the first part. So if we leave off if, an inscribed angle of a circle intercepts PT intercepts the diameter if and only if the inscribed angle is a right angle. If and only if. So if and only if means an inscribed angle intercepts of a circle intercepts the diameter, then the inscribed angle is a right angle. And then you can reverse it. If the inscribed angle of a circle is a right angle, then the inscribed angle intercepts the diameter. And give yourself, again, a mark for the converse and a mark for the statement. So 2 marks altogether, so 5 for that page. Number 4, a chord of a circle 16 centimeters long is 6 centimeters from the center of the circle. What is the area of the circle? So to get the area of a circle, we need a radius. So let's draw the circle. And we have a chord that's 16 long, and the chord is 6 centimeters from the center. So let's say O is the center, and it's 6 centimeters from the center. So 6 centimeters means it's the perpendicular distance. The distance from the center is understood to be perpendicular distance from the center. We're not going over here or down right here. We're going perpendicular to the chord. Because it's coming from the center, because this segment is from the center to the chord, then it bisects the chord. So it makes the chord 8 and 8. That means we have a right triangle. And in this right triangle, we have the hypotenuse. So the hypotenuse could become the radius, because I need the radius of the circle. So we have c squared is a squared plus b squared in the right triangle. The radius is the c, the a and the b is 8 and 6. So r squared is 36, 64. R squared is 100, and r is plus or minus the square root of 100. So r is equal to the positive 1, so it's 10. And so the area of the circle, area is pi r squared. Pi, the radius is 10 squared, so that's 100 pi. And the units are in centimeters, so this is centimeters, and the area is in square centimeters. So 100 pi square centimeters is the answer. And if you have the 8 and the diagram, you get a mark. If you have the 10, you get a mark. If you have the area, you get a mark. 3 marks altogether. Number 5, 2 parallel chords of a circle are on opposite sides of the center. And they're 4 root 6 and 6 long. If the diameter is 12 centimeters, find the shortest distance. That's the exact distance between the chords. So what we have is a circle. And we have the center. And there are 2 parallel chords on opposite sides. So let's say one is here and another one is here. So the longer one, so let's say this one is 4 root 6 and this one is 6. And they're parallel to each other. Okay. And the diameter, it says the diameter is 12. Since the diameter is 12, 2r is the diameter. So r is 6. So we need to get the distance. You need to get the shortest distance between the 2 chords. And the shortest distance between the 2 chords is the perpendicular distance. So this is the center. This is perpendicular here and perpendicular there. So the perpendicular distance between the parallel chords is the shortest distance. And we have a radius of 6. So we make a triangle here, right triangle. We make another right triangle right here where this is the radius. So this is 6 and 6. We have perpendiculars. Now, because it's from the center perpendicular to chord, so it makes the chord 2 root 6 and 2 root 6. And this is 6 long, so this makes this one 3 and this one 3 because it bisects it. From the center perpendicular to a chord bisects the chord. So I'm going to call this one x, distance, perpendicular distance from the center. This is the perpendicular distance from the center to this chord, so I'm going to call it y. So I'm going to do 2 triangles. I'm going to do this one. And so this is, we have 6 squared is x squared plus 2 root 6 being squared. So that's 36 x squared. And 2 times 2 is 4, root 6 times root 6, root 6 times root 6 is 6, 4 times 6 is 24. So x squared is 36 minus 24, which is 12. So x is plus or minus the square root of 12. X is plus or minus 4 times, that's 4 times 3, so it's a 2 root 3. So x is positive 2 root 3. Now we have another diagram right here. So we have 6 again, so 6 is being squared, and we have a y squared plus 3 squared. So that's a 36, y squared, 3 squared is 9, so y squared is 36 minus 9 is 27. So y is plus or minus the square root of 27. And 27 is a 9 times 3, so square root of 9 is 3, so that's a 3 root 3. So y is a positive 3 root 3 because it can't be negative. So the distance, I'm going to call distance d, is 2 root 3 plus 3 root 3. So the distance between the two parallel lines is 5 root 3. And there's 6 marks for that. So if you get the diagram drawn, you get a mark. If you got the radius, you get a mark. If you have the right here, 2 root 3, and you have 3 root 3, and you added them up. So there's 2 for the diagram, or also there's 1 for the diagram, and because it's perpendicular bisect, so if you got 2 root 6 each of these, you got 3 on each of these, there's 2 marks here, so 6 altogether, 9 for the page. Okay, let's continue. Number 6, we have a circle. It says O is the center. The measure of the arc AB is 290. So the measure of the arc ABC. So 290 is the measure of this arc right here. That means 360 is all the way around, one complete revolution. So 360 take away 290 is 70. So that means the measure of this arc is 70. And that means the angle AOC is 70, because the central angle has the same measure of the arc, and there's 1 mark if you have the central angle to be 70. Number 7, we have a circle. It says again, O is the center. It says the measure of angle OFH is 25. OFH, so this is 25 degrees right here. And it says find the measure of the angle FTH. So if this is 25, we got to get the measure of this angle right here. So OF is equal to OH because the radius of a circle are equal. Because the 2 sides of a triangle are equal, the angles opposite those sides are equal, so this angle is also 25. So 180, and that's 25 and 25 is 50. So that means that this angle right here at O, the central angle, is 130. If this angle is 130, the arc FH is 130 because the central angle and the arc are the same size, same measure. And this angle FTH intercepts this arc, same as the central angle does. So this angle here is 65. 65, because it's half the central angle. And if you have 65, give yourself a mark. Number 8, O is the center of the circle. NI is a chord. NI is a chord because that's a chord passing to the center. Then NI is a diameter, so that's a diameter. And because that's a diameter, I have an inscribed angle here. This inscribed angle NPI intercepts this diameter. So that means that this angle here is 90 degrees. Because this arc over here is a semicircle, 180 degrees. So this is an inscribed angle intercepting this arc, 180, so it's half of 90. Or this inscribed angle is intercepting the diameter, which is 180 degrees, so therefore it's a 90. So either way, we have a 90 here. That means we have the angle NPI I is equal to 4x plus 10. So that means that 4x plus 10, which is equal to 90 degrees. That means 4x is equal to 90 minus 10. 4x is equal to 80 degrees. Divide by 4x is 20. Now, we have x. We're given that angle n, which is this angle, is 2x plus 20. We want to find what the arc NP is. The arc NP is this arc here. So to get this arc, I need to get this angle, because this inscribed angle here at I is half of this arc. So if I want to get this arc, I need to get this angle. So we have x is 20, so let's put angle N is equal to 2x plus 20. So x is 20 degrees. So 2 times 20 is 40. And 40 plus 20 is 60. So that means this angle is 60. So we have a right triangle. That's a 90 and a 60. That's 150. That means this angle is 30. And since this angle is 30, this arc is, the inscribed angle is half the arc. That means the arc is double the inscribed angle. So that means the measure of the arc NP, let's make that an arc symbol, is 60 degrees. Again, we had to know that that was a 90 because it intercepts the diameter. And so if you have your 20 degrees, you get a mark. If you have the 60 degrees, you get a mark. If you have angle I is adding, this angle adds up to 180, this angle I is 30, and you double it to get 60. So there's your 4 marks. Total your page. Hopefully you have 6 out of 6. And let's continue. Now we have another question. It says that the arc, we have a circle, and you can see that 2 chords are marked equal. So these 2 chords are marked as equal. And it says that the measure of the arc AB is x plus 95. The measure of the arc AC is 2x. Find y, which is this angle here. So we're given that 2 chords are equal. That means the 2 arcs are equal. So if the arc AB is x plus 95, there's the arc AB. The arc AC is 2x. Since 2 chords are equal, the 2 arcs are equal. So these 2 chords are equal, intercepting these 2 arcs, AC, BC. That means this arc is 2x. And now that we have all the arcs in, that means we have x plus 95, add on 2x, add on 2x, equals 360. So they all add up to, all the arcs add up to 360. That means that 5x is plus 95 is equal to 360 degrees. That means 5x is equal to 360 minus 95 is 265. And divide by 5 and you get 53 degrees. So that means x is 53 degrees. Now, if we want to get angle y, angle ACB is intercepting this arc, so this is an inscribed angle. So I need to get the measure of the arc AB and then take half of it. So the measure of the arc AB is equal to x plus 95. And so x is 53 plus 95. So that means that it adds up to 148. So this arc is 148 degrees. So that means y is 148 divided by 2. So that's a 74 degrees. So hopefully everything worked out. Again, if two chords are equal, then it intercepts equal arcs. Or if two arcs are equal, it is intercepted by equal chords, etc. So if you have your diagram, you get a mark. If you have the equation, you get a mark. If you solved it to get 53, you get a mark. If you got the 148, you get a mark. If you took a half and got 72, you get a mark. 5 marks altogether. Number 10, parallel chords of a circle intercept equal arcs. So now we have to do a proof. So let's do an official proof. We got the givens and we got what we got to prove. So what are we given? We're given a circle and say, let's call this circle. This circle has a center O. So we're given O is the center of this circle. And we're given two parallel chords. So we have, let's draw one chord right here, and let's draw another one right here. So this is the chord AB. This is the chord CD. So we're given two chords, and the chords A, B, we're given A, B, and C, D are chords. And also we're told that AB is parallel to CD. So we have to prove that the arcs AB, which is this one, is equal to this arc here, which is CD. So we're based on this statement, this is the givens, and this is what we have to prove. So I'm going to take a shortcut. That's number 1 right there is the givens. So I'm going to take all those givens and move them in right there, just to save time. Now, I get that done. So now I have to draw, I have to join this up. So number 2, I have to draw AD. I have to draw chord AD, and that's what we call a construction, because between any 2 points we can draw a line. So we're going to draw this chord AD. Number 3, I'm going to label this as angle 1 and angle 2, so I don't have to go B, A, D, and C, D, A. I'm going to call this 1 and call this 2. So we have AB is parallel to CD, and that's a given. Oh, we already got it in the given. So that means, I don't have to say that, that's already in the given. So angle 1 is equal to angle 2. That's what I call the PLT. Because I have two parallel lines, because that line is parallel to that line, angle 1 is equal to angle 2. PLT. If two parallel lines are cut by a transversal, the alternate interior angles are equal. So PLT, and I'll write down alternate interior angles are equal. That's what it means, PLT. Alternate. It could be corresponding angles equal. Could be other reasons. And we have number 4. We have angle 1 is a half of the arc BD. And we also have angle 2 is a half of the arc AC. I better make sure that's a half there. Half of the arc AC. So angle 1 is a half of this arc, because it's intercepting. This is an inscribed angle intercepting this arc. Angle 2 is this angle intercepting this arc. So angle 1 is a half of BD. Angle 2 is a half of the arc AC. And that's the inscribed angle is half the intercepted arc. So the inscribed angle is half the intercepted arc. The inscribed angle is half the intercepted arc. And number 5, notice we got 1 is equal to 2, so we got a half of BD equals a half of AC. And that's the transitive property. Transitive property of equality. Just take some shortcuts here. And because we have a half of BD equals a half of AC, we can divide by a half. So the arc BD equals the arc AC. And this is an arc. So that's, we can do the division. There's the division property of equality. Because it's a half, number 5, because a half is on each side, dividing each side by a half gives me the arcs equal. Instead of half of them equal, the full arcs are equal. Division property of equality. And if you go down through, you got 6 marks. So if you have the given written correctly, and if you have each of these statements like this, you get 6 marks in total. That's 11 for that page. And we've got one more question to do to finish off this review of the first, I think it's 13 videos. We have a diagram, and this is always the center. It says that the arc AB and the arc BC, so this arc is 148. This arc is 148. They're both equal to each other, equal to 148. So I want to get the measure of the angle BAO. So there's a couple of ways to do it. One way is, the shortest way to do it is, I want this angle BAO. I want this angle right here. So one way is that the angle BOA is equal to 148 degrees, because the central angle BOA is the central angle right here. It's the same size as the intercepted arc. Now we have that OB is equal to OA, OB is equal to OA, because radii of the circle are equal. So these are equal. So that means that this angle here is 148, and these two angles are equal. So if you take 180 in the triangle and subtract 148, you will get a 52. Oh, 52. If I can subtract right, 32. 180 subtract 148 is 32 degrees. So that means these two angles, this one and this one, add up to 32. So 32, because two sides are equal, two angles are equal, 32 divided by 2 is 16. So this angle right here is 16 degrees, which is what we have to find. And if you said the central angles were equal, and you said the radii were equal, and came down to get 32 for the difference, or you can take 32 and divide by 2 to get 16. So there's 3 marks in here. Again, 148 central angle, and if you said that these two sides were equal, making the angles equal, is another mark, and you divide it by 2 to get 16. So that's 16 degrees, you get 3 marks. And there's another way to do it, but just a little bit longer. And we could, I'll do that one very quickly. So this arc is 148. That means that this angle right here is 74. This arc is 148. This is an inscribed angle. This inscribed angle, BAC, is intercepting this arc. So this inscribed angle is half of the arc. Now, that's 148 and 148. That makes 296. So that means the arc AC is 64. If that arc AC is 64, this central angle is 64, same size. And so 180 minus the 64 gives us 116. So that means these two angles add up to 116, this one and this one. So a half of that gives me a 58. So this is 58, this is 58. And so the large angle right here is 74. And you subtract 58 and you get 16. But the quicker way would be to do what I did first. This is the central angle of 148. These two sides are equal. These two angles are equal. You get 16 right away. And the other way is a little bit longer, but it works. And 3 marks for that page. And all together, add up all your pages, come back to the first page, and you have it at a 34. Total up your number that you have. Divide 34 into your numerator, get a decimal, move it 2 places to the right to get a percent. So this ends the review on the first 13 videos. And if you like my video, click the like button, click the subscribe button. If you want to subscribe to my channel, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.